guys another session which is set. We are still dealing with the data structures, so you guys should understand data structures when it comes to list, tuple, sets, and dictionary. Okay, and now our second lesson for today is sets. Okay, now let me select my kernel. You know, I've created a notebook here. I'll select my kernel, and now inside my kernel I'm going to have what we call my VMV, which is virtual environment, selected correctly. And then inside, let's set our markdown so we can know what we are going to learn. So what's a set? Or let's say, so basically sets are built-in data types, okay? So they are built-in data types. So the moment you hear of built-in, it means it's already part of Python, okay? That you can use it anywhere at any point in time, okay? So I just said, what's the name of what things such as end is categorized as any other example of set? Oh, we are done with tuple. Ade, please join our Discord. You can post this thing there, and then I'll help you out. Okay. All right. So we are looking at sets are built-in data types in Python used to store these kind of collections of unique items. Okay. They are unordered, meaning that the elements do not follow some kind of specific order. Okay, so they are ordered. Unordered means they do not follow any specific order, so they can be anything. So we are saying that they are unordered. Okay, they are unordered, and they are what? Meaning they do not follow some specific order. Okay, and they do not allow duplicate elements. Do not allow duplicate elements. Okay, so we are saying that they do not allow duplicate elements. All right, so now what we need to understand is we are going to look at so many scenarios how we can create a set and order. So let's look at that. Let me bring up a code here. Let's look at how we can create a set, because set is not that long, so we will finish right now. Okay, so let's look at how we can create a set. So let's say I have a variable, say my underscore set. Okay, so now with this variable my underscore set, I want to assign it to. Now let's look at how we assign a set. You bring this. Now take note of this particular sign. Can someone type in the comment section what this means? What does this mean? Like the bracket. What is the full name of this particular bracket? Yes, in the comment section. So yes, I'm waiting for the comment section. What does this mean? Like we have open square bracket, we have curly bracket. Okay, curly. Oh, I've already mentioned. I've already mentioned. All right, that's good. Yeah, you guys are really amazing. Yeah, so curly bracket. Okay, so with this is how sets are being assigned. Okay, if you want to use set, this is how we assign it. And now inside it, you pass your your arguments or your items or your elements. So I could say 1, 2, 3, 4, 5. Okay, and then when I print this, let me use the print so it doesn't tell me I need to. So print, what are we printing? We are printing my underscore set. Okay, so once I print this, you see, now let's look at the type of this, so we will know that yes, it's a set. Okay, so all that I need to do is I can copy this entire one here to the next line like this, and then inside the print I will just type here type. Okay, then I'll put it inside the bracket again like this. Okay, now let's run this. So you see, it's telling that the class is set. It means we have set our set. That's why we are dealing with set here, right? So now you see we created a set, and this is the set. How we create a set, sorry, and how we can print a set, and how we can check for the type, the data type of this particular set, or this particular elements we have assigned to this particular variable. So when we assign or define a variable with these elements or items, we need to understand what type is it. What data type is it? Is it a set? Is it a tuple? Is it a list? And here it's telling us that what is what? A set. Okay, guys? All right. Now, let's say we have, um let's do something like, let's look at something. Let's look at something. So let's say, let's use the mindset. Okay. Okay. Let's use the mindset. Okay. So mindset, should I use set my, no, let me use my underscore empty. Okay. Empty underscore set. Okay. So my empty underscore set is equal to set. So now let's look at this type. This is a variable, and this is a method, inbuilt method. Remember I said sets are what? Inbuilt. Okay, meaning they are part of Python. So now I'm saying that my empty set is equal to set. So already I am using the inbuilt function for set, or inbuilt method for set. Okay, so when I come here, and I say set this, so once you say set, it means you want to use the inbuilt function. That's why you bring the open and close bracket. Remember, the moment you start using the set inbuilt method or function, you don't set it like this. But when you are setting it by yourself and not using the inbuilt function, then you need to bring the curly bracket. Take note of this, okay, guys? All right. So now we do something like this, and then we will say that, okay, now what will be the type of this? So I just want to get this copied. Come here, print. Inside the print, I paste this. Now the same thing. Oh, sorry. Inside this, I paste this. Let me copy this one. Okay, we don't have, it's empty, so let me just put a type here. Okay, you open and close bracket. We just want to know the type. Okay, if it will still say it's a set. So you see, we are still getting set. So it tells us that when we can create our own set like this, or we can use the inbuilt set. Take note, guys, we have two ways. You can create your own set like this, which will still get a type to be set, or you can use the inbuilt set and still get what? Set. Okay? Alright, but mostly what we use is the inbuilt one. But if you have any reason of creating your own set, you are good to go. No war. Okay. All right. So now let's look at how we can then set our own. We can set a set inside this. Okay. So let me copy this variable entire one. Come here, and then let's paste it here, and let's say my set. Okay. So now we are saying that my underscore set is equal to set. So inside this set, let me convert a list into this set. So let's say 1, 2, 3, 4, 5, 6. Yeah, it's okay. So this is a list we are converting to be a set. You get a concept. Now you get a concept. So I can just print my entire list or set here. Okay. So when I run this, you see the curly bracket is popping up. It means this is a set. You need, so I only converted this particular list. Okay, you see this is a list. I converted it to be a set. That's it. Now you know these techniques, so I don't need to even worry myself on. All right, that's good. So what we need to do is, what are we going to do here? Let's do something like, let's set, let's do the same thing. Okay, let's do the same thing and see something. Let's do the same thing here, the same thing here, but this time around we say my empty underscore set is equal to set 1, 2, 3, 4, 5, 6. Okay, so let's print this one. Let's print this. It's the same thing. So you see, you're getting the same thing, right? It's just the variable name you change, right? Now let's look at some basic operations. Okay, so we understand what I just did. Okay, let's look at some basic operations. All right. Okay, now what is this hashtag? Basic operations. Now we are looking at basic operation, so we understand the concept. Okay, so now what I'll do is, let's look at adding and removing first. Okay, adding and removing. All right, so with adding and removing, what I'm going to do is, now you know I have set some things here. I have set my set and I've set my empty set. Okay, so I'm just going to call this my set. All right, so when I come here, I will just say my underscore set. Okay, dot. See, I'm going to use the add method. It's as simple as that. Dot add. What am I adding? Let's say my set was up to what? 6. So let's add another one, 7. So I just put here 7. So this is how we add. Okay, and it's as simple as that. I can just call the variable and print it. So print my set. Okay, it's as simple as that. I can go another way and then still say my set dot add. Okay, and I will say what should we add? Let's say dot add. What should we add? Okay, let's add the same 7 and see something. So we add 7, we print. Okay, so we print the same thing. See you. So now if I run this, okay, let's run this. So you see what I'm getting? I'm saying that my set print this, my set print it. So I've added 7, 7. So I'm getting different 2 sets. You see, I'm getting 2 different sets. You see the difference? No, here we don't use append. That's a good question. Here we don't use append, we just use the inbuilt method, which is dot add. Now let's look at another scenario. Let's remove, so you understand. Let's remove. Okay, so if you say we want to remove, let's say we use the same variable. We use the same variable, my underscore set dot what remove. It's as simple as that. What are we removing? Let's say we want to remove 3. Okay, so if you want to remove 3, that's it, and then we just print. We just print my set. Okay, and then when we run this, this should give us there wouldn't be any 3 in our set. Yes, pleasant. Yes, add puts the new value. Yes, at the end. Yeah, so it continues. So you can add so many one using the dot add method. Okay, which is an inbuilt function or method. All right. So now let's look at something. Let's say we do something like this. Okay, let's say we do something like my underscore set dot remove. Now we don't have 10, isn't it? But let's put 10 there and see something. You'll get error. But let's look at the error. Okay, so you see, it's saying that key error 1 my underscore set dot remove 10, key error is 10. So it means that we don't have any item or element in this particular set that is 10 and we want to remove. So there's some kind of key error. So take note of this, guys. Okay, all right, if you don't have any item, don't go and reference it, else you get a key error. Can we specify the exact index? Can we specify the exact index no, here set we don't specify any index, we just use those inbuilt. You remember I told you sets are inbuilt methods, so you just go ahead with it's rather tuples and lists that we deal with indexes. Okay, a lot. No, we don't append. Appending is where we use the add. Okay, all right. So now let's look at but in set we will pop means so let's look at another scenario. Okay, let's pop and see. Let's pop. So let's pop let's use the pop method. Let's see how we can use the pop method so you get clear. Okay, let's say removed what should I do it? How should I do it? Let's say removed element. Okay, let's say remove element is assigned to how should we do it? Okay, let's pick our set. Okay, guys, let's pick our set. We have my set. Okay, so removed underscore element is equal to my set dot pop. Okay, what are we popping? Then we come here, then we can say print. What are we printing? So let's print remove element. So we'll get the mindset, all of them, and we print. And now let's also print the mindset. Okay, so let's print mindset. All that we are doing here is we want to pop. Popping means you want to pop some kind of element out, okay, by removing that particular element out of the set. Okay, yes, you only append in list. So we want to pop out a particular element or item from the set, so that it's by removing it from the set. Okay, so when I run this, right, you see, what did we pop? We pop some element from the list. So we are saying that remove elements go to my set pop. I just pop one out. You see, I just pop one out, and that's it. You don't do anything. So you can pop a particular element out by just picking the first one, or you can specify. Because I didn't specify, you just pick the first one. I can pop, let's say 5. Let's run again. So I'll get error. It means we don't want set pop takes no arguments, one given. Okay, so it doesn't take any argument. That is why I left it here blank. So when I run, it only pops. When I run again, it pops. When I run again, it pops. You see? Yeah. So just take note of how you use the pop. Okay? Alright. Now let's look at how we can clear. I told you set is very simple. How we can clear all the elements. Okay? How we can clear all the elements in a set. So all we can do is my set dot, and then we say clear. Okay? And then that's it. My set dot clear. That's it. And then when we print my set, we should get set is equal to what? Empty. You got a logic here? My set dot clear. Then we print my set, and when we print, because we are clearing everything inside this, everything here we are clearing, so we are seeing what? Empty set here. You see, the set is empty. Good. Now let's look at how we can set something we call membership one in a test. So set membership test. So let's say set membership test. Okay, so this is also very simple. We bring my underscore set. Currently it's empty, so let's assign to something, right? So we bring the curly bracket, and then we say 1, 2, 3, 4. Should we get, where should we get 5? Okay. So let's say my underscore set is inside the curly bracket. 1, 2, 3, 4, 5. Okay, now what do we do? All that we are going to do here is we are going to print like this. Okay, now inside this our print, okay, we are going to make sure that we set some membership. So we can say 3 in my set, 10 in my set. So let's say something like this: 3 in, then we bring my set. Okay, then we set another one, another membership. So print into bracket, we can say 10 in my set. Now all that we are doing here is that it will check, is 3 a member of this set? If it's true, it will print the boolean true. It will check, is 10 a member of this my set? If 10 is not a member, it will print the boolean false, and automatically we should get true for the first one and false for the second one, isn't it? Because yes, 3 is a member, this is it. But when you click on 10, we don't see any highlighted here. So 10 is not part. So let's run and see. So you see we have true and we have false. You get the logic? So we can also set membership to test something. So sometimes, that's why I told you here, if you think that particular thing you are removing is not part, or you don't know, you can set membership. Okay, you can set membership here, and then based on that, you'll be able to know which one is inside the set and which one is not part of the set. Since tupels are, Mayor said, do we also sort tupels and sets, or is only list? No, we don't sort tuples, so it's only list. Since tuples are immutable, can values be added or removed? Can values be added or removed? No, the only way you can add or remove any tuple is, as I said, when you convert into a list, right? And I explained all that when we had the tuple session. Okay. You only have to convert. So you have to convert the tuple to list. That is where you'll be able to what? Be able to what? Do all your changes, adding and all that. Okay. Without that, you can't change anything. It's immutable. Note that. Okay. All right. So now let's look at some mathematical operations. Okay, which is very simple. Okay. Mathematical operations in sets. Okay. Mathematical operations in set. So let's say we have set 1. Okay. It's assigned to. Let's do the math here. So let's say we have 1, 2, 3, 4, 5, 6. Okay, and then let's set another one. Set 2 is equal to another set of 4, 5, 6, 7, 8, 9. Okay, so this is our two individual sets. Okay, now with these two individual sets, what we are going to do is we want to know one. Let me run this first, or let me go below it. We want to know one, the union. You remember these masses? The union. We want to know two, the intersection. Okay. Oh, sorry. So we want to know the union, the intersection. You guys remember this? Then we move on to the different, the symmetric, all these things when we were in primary 6 and all that. So now let's look at how we can know the union. Okay. So union, you know unions, right? So let's look at how we can get the union. So all we need to do is, let's say we give a variable called union underscore set. Okay. So union underscore set is equal to set 1, all right, dot union of what? Set 2. Okay. So all that remains is that a set 1 is union of set 2. That's it. And we understand unions. So if we say a set 1, okay, a union of set 2, and if it's yes, then we should print the union set, which is this one. Then print it. If it's not a union, we will get nothing, right? Now let's set another one. Let's say intersection. Okay, we'll run them later, don't worry. Intersection underscore set is equal to set 1, the same thing, set 1 dot intersection, which is an inbuilt. Remember, I'm using inbuilt methods. I'm using the union set method. I'm using the intersection method. You see, it's set 1 a union of intersection of set 2. Set 2. So all this means, are they intersecting? Are they intersecting? Are they union? Okay. So if they are not, we don't get anything. If they are, we get result. So all that is all that it means. And let's print what? Print what? Intersection underscore sets. So that, you see how we are doing the math? You see, we first set our set here, then we did the math here that okay, set 1 is set 1 a union of set 2, then we print. Is set 1 an intersection of set 2, then we print. And now let's check for some updates. So let's say set 1 dot intersection underscore update. So we have another one called intersection underscore update. It's also an inbuilt function of set 2. Okay, and then if it's yes, we print, then we print set 1. Set 1. Okay, so then update. All right. So now you see, now when we run this like this, okay, you see, we have what? These two sets. So this first one is set, and then the second one is this. And we are saying that we want the union, which is the all, union of set 1, union of set 2. So that's why we are seeing all here. Okay? What's the union? We see that 1, 2 is not part, 3 is not part. So the union will be 1, 2, 3. And then we will not pick 4, 5, 6 because it's also part here. So we start 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the union of what? The set. The intersection. Are they intersecting? So let's see. Yes. 4, 5, 6, 4, 5, 6. So they are intersecting. That's why we got the intersecting. Now let's look at the update. So set 1 dot intersection update set 2. Yes, we still get the same thing because when we update it, we still get the same. They are updated to the same thing. So it means they are still intersecting. That's it. Okay? And that's it. You don't have to learn anything else. It's the same concept back in our days when we have that kind of mass and all that. Okay? So let's look at this difference. Let's look at difference. So let me pick so we don't have to waste time. Let me pick this. Let me pick this. Okay, let's put it here. Okay, now we want to know the difference. So print into brackets set 1 dot the difference. Okay, this is an inbuilt function or method. Print dot set 1 dot difference of what? Set 2. Okay, so all that I mean is I want to find the difference between set 1 and set 2, and once I run this, the difference is 1, 2, 3, which means that 1, 2, 3 is the difference. It's not bad. Okay, that's the whole concept, right? Okay, we can also do something like set 2 dot difference of what? Set 1. You see the same derivative, so it's the same thing. We get 7, 8, 9. So you see, first one we did set 1 dot the difference of set 2, and now we are doing set 2 the difference of set 1. It's the same thing, right? Now let's look at another concept, which is set method. Set method. Set methods. Okay, let's look at set methods. All right, so set methods are basically some kind of subset, superset, and all that. You remember all those things, subset and superset. So it's all about that kind of those mass, that concept. Okay, so we can have, let's say, set 1 is assigned to, let's say, 1, 2, 3, 4, 5. Okay, and then let's say we have set 2 to be equal to another one, which is, let's say, 3, 4, 5. Okay, now this is the two different sets, and let's say we want to see is a subset. Okay, is set 1 a subset of set 2, or is set 2 a subset of set 1? So we want to know if they are subset. So we can say print into bracket. Okay, then we say set 1 dot, okay, set 1 dot what? Is subset. You see the way I'm writing an inbuilt function? Print set 1 dot is subset, and this is an inbuilt function, so you bring it like this, and then is a subset of what? Set 2. And then we move to the next line, and then we can also say, but let's first print this. Okay, you see it's false because set 1 is not a subset of what? Set 2, which is false, and it's correct. Now let's look at another one. Print into bracket set 1 dot is a superset. Is it a superset of set 2? You see, and this we can as well print, and it will say true. Yes, set 1 is a superset of set 2. See, 3, 4, 5 is a superset of set 2, which is true. All right, so that is how set works. And We can even look at one typical example. Let's look at a typical example, then we are done with set. So let's say we have we want to count unique. We want to count unique words in a test. Okay. Let's say we want to count unique words in a test. So let's say we have our test to be equal to what should we do? Okay, let's say in this tutorial, okay, we are discussing about sets. So I'm using our tutorial, okay. So we are saying that we want to count the unique words in this particular text, okay. And I'm saying that in this tutorial we are discussing about what? Sets. All right. Now I will say that words is equal this a variable, text this a variable. So this variable text, okay, I'm bringing it here. So words is equal to text dot what? Dot what? Let's split it. Let's split the text. Okay. Now, once we split the text, I am going to convert because I want to count the unique words in the text. So I'm going to convert. Okay. I'm going to convert. We are looking at a typical example. Okay. We are going to convert the list. Okay. The list of words to sets, okay, to get the unique words. Okay. So what we'll do here is we will just say a declare variable, say unique underscore words. You get a concept here. Unique underscore words is equal to set. What are we setting? The words. Okay, the words. And when we set the words, what do? We just print. It's simple as that. We just print this unique words. Okay, we just print this unique words, and also because we want to know the uniqueness, we just print the length. Okay, the length of these unique words. It's as simple as that. And when we run this, you will see that this discussion set in about we, so it will count. So 1 2 3 4 5 6 7 8. You see, so now it's what? 8. It's as simple as that. We just count the unique words in a text. So each word, this word will be counted as 1, this will be counted as 2 3 4 5 6 7 8. And I just use this simple code to count it. You just convert the list of words to get a unique set, and then we just print. That's it. All right. So this is how sets is, and sets are powerful and flexible data type which you can use in Python. I will provide more flexible way for you to store collections of what? Unique elements. If you want to store some collections of unique elements, then you should use list with your Python code. Okay.